Hello friends, good afternoon everyone. Today, just we are going to understand the behavior of sin x function as per the angle changes, and we also need to understand how it will affect the amplitude of the graph. So before we get into the main concept, just recall domain and range of sin x function. As you know that sin x function where domain is basically real numbers. It means that for every real angle, the sin x function is defined as well. The range of sin x function, which you have studied in grade 11, that is 1 to plus 1, means the least value the sin x function may attain is minus 1, and the highest value the sin x function is attain is plus 1. So we also know the basic graph of sin x function. With the help of sin x function graph, we are going to understand its behavior, its frequency, its wavelength, and amplitude in terms of domain and range when the angle gets changes. So let's experience the same graph through GeoGebra tool. Let me share the screen for the same. Yes, children. I hope you are able to see the screen. Now let's see the graph of sin x through GeoGebra tool. It looks, see, the graph is on the screen. It looks like a beautiful curve, which is periodic at every 2 pi interval. And you may also see the basic things of this graph, like the highest point is 1 and the lowest point is minus 1. It means the highest value the graph can reach is 1 and the lowest value the graph can reach is minus 1. You can look at these points where I'm highlighting these points to understand the basic nature of this graph. Look at see. So the highest point, as you can see here, at 1 and the lowest point is at minus 1, which will decide the amplitude of the wave. In mathematics terms, the amplitude of the wave is considered to be a range of sin x function. Hence, the amplitude of the wave is plus 1 to minus 1, is highest point and lowest point. And in the same way, the range of the sin x function is plus 1 and minus 1. Now we are going to experience how this range get changed when the angle get distant. How? Let's see this one. I'm going to sketch the sin 2x graph, and we will observe and the changes in its amplitude as well. Let's look at this graph with blue colored highlighted one, blue colored with the blue color one. You can see that the graph. Just for your reference, I'm just differentiating the thickness. Right. Now look at this. If you look at this graph, it doesn't change its height and the lowest point of the graph. Highest point of the sin 2x graph, which is highlighted in blue color, is 1, and the lowest point is minus 1 everywhere in the graph, which shows that when you alter the angle, means the value of x in the sin x function, it doesn't change the range of the function. It means the highest point and the lowest point of the graph remain same, which says that range of the function is minus 1 to plus 1 as sin x graph. You may also experience the same by drawing the another graph. Again, we are going to change the angle. I'm multiplying the angle by 4, which gives you sin 4x graph, which is basically highlighted here with the red one. I'm just changing the color here, just to understand it. Okay. Just I'm showing with an orange color. The orange color graph, you can see for your reference, I'm changing the thickness to. Yeah, you can see. The highest and the lowest of the orange color graph is showing by sine 4x. Highest is 1 and the lowest is minus 1. So from these three examples like sine x, sine 2x, sine 4x, in all the graphs you can see the highest and lowest points are in. It means range does not get affected with the when you change the angle. So which shows that range of the sin x function does not depend upon the value of the angle. Yes, of course, the wavelength of the sin x graph definitely will change when you change the sin x function, right? Like the coefficient of sin x function. Suppose I am taking one last example to understand the change in the amplitude. When suppose the sin x function is multiplied by suppose 3, you will see the immediate change in the amplitude of this graph. The highest point will reach 3 and lowest point is minus 3, which says that when you multiply the sin x function with any coefficient, any that wavelength, sorry, amplitude will get changed in that much times. I hope this graphical interpretation definitely help us to understand the behavior of sin x function when it is changes. Yeah. So now coming back to the conclusion of the topic. Yes, sin x function will definitely change the amplitude when that completely sin x function is multiplied by the non-zero constant. Otherwise, when you change the angle with any constant, multiply, divide, and all, it doesn't affect the amplitude of the sin x graph. That is, it doesn't affect the range of the sin x. Okay. See you all then. Take care. Thank you for watching me.